All right. With nothing further ado, welcome everybody. Welcome on the stage for data security and cloud at the Bitkom Privacy Conference 2022. My name is David Schönwert. I'm a policy officer at Bitkom, and I'm happy to have you here with us today. Maybe some housekeeping. Feel free to put questions into the chat. We'll try our best to ask these questions to our guest Omar, to tweet and again share your thoughts about this conference. Wonderful. So this is the first session. I have with me Omar Fdal, who is the CEO of Statice, and his our kind of conversation has the title "Insights Not Secrets: How Synthetic Data Empowers Privacy." So I'm very much looking forward, Omar.
Thank you very much, David. Thank you for the Privacy Conference for inviting me. Happy to be talking again this year.
Wonderful, can't wait. All right, Omar, let's dive right into this. Maybe just start a bit easier. What is it that you do at Statice? What is your work about?
So Statice is a Berlin-based company that develops data privacy technologies focused around synthetic data. And we help organizations protect customer privacy while gaining insights from data for research or business developments, decision-making, and of course, while safeguarding the privacy of individuals. We founded the company back in 2018, right before GDPR came into effect. And of course, GDPR hugely impacted the way organizations used data. So we provide data anonymization software and services that allow our customers and their partners to create privacy-preserving synthetic data that is compliant for any type of data integration, processing, or dissemination. In a nutshell, our mission is to avoid the compromise between data privacy and data innovation.
That sounds super interesting, because there seems to be a bit of a tension between these two, but it seems that you say you can avoid this. And I heard you want to do that using synthetic data, or you are doing that using synthetic data. What is synthetic data? Some people might not know.
Yeah, indeed, that is synthetic data. When we started, was a very new concept, and at the time, very few people knew. Today, the situation is different, but it's always good to introduce the concept. Synthetic data is the outcome of artificial data generation. So a new data set is created, and this data set has, in general, similar characteristics to the real data. So it resembles the format of the original data. It retains its statistical distribution. It means that synthetic data really looks like and behaves like real-world data. It's defined by two essential aspects. The first one is that it's artificially generated. In other words, it has no direct link to real events or real people. The events and the people it represents are completely artificial, and they are generated by algorithms. The second aspect is it is realistic. So artificial data, of course, that doesn't mirror the original data. It cannot be useful for analysis. And this is the two essential aspects. And then there are two ways that synthetic data can be created. There are many ways, but they fall into one of two buckets. The first one is when it's based on previous knowledge. So if you know laws that govern a specific situation, models or rules or probabilities, you can use them to simulate new data. The other way is to create it directly from the real data, which is usually accomplished by using machine learning algorithms or artificial intelligence or statistical learning that learn the distributions and relationships within the original data set. And then once those relationships are learned, we generate and sample new artificial records.
I see. It sounds very complicated, but it does sound very interesting. It sounds very powerful. Also, kind of using math and statistics to kind of create data that is has certain characteristics, but is kind of is not copied, but is generated from scratch. Okay, maybe also then regarding somehow the application, like from a kind of privacy side. So you say this is relevant because it resembles real life data, but it isn't. And so I assume that you can like still do similar calculations analysis machine learning on this kind of data, even though it's like a clone kind of the original data?
Correct. Synthetic data really has emerged as a technological solution for organizations to achieve privacy compliance and at the same time data access. And the fact that you can run those analyses, so machine learning models, analytics, or research on that clone, makes it really useful in real world scenarios, because it's not only dummy data that you can use for testing or to pre-populate some of the product development activities. Now you can actually do advanced analytics on this data. And because the process of generating synthetic data completely breaks the one-to-one relationships between the original, the sensitive, and the synthetic safer records, this breaking of the links minimizes the chances of re-identification or minimizes the risk of exposing original sensitive data. So this process of breaking the links makes it irreversible. So there's no key that allows you to conveniently trace back or retrieve original records based on those synthetic records. And this is already a very strong and desirable property in any privacy preservation technology. Now, of course, zero risk does not exist. And as with every data processing, it is important to understand that residual risk of producing and using such data. And so at Statice, we combine two complementary approaches to data privacy. The first one is privacy by design, and this is achieved by making sure that the core algorithms used to generate this data are themselves privacy preserving. And the second approach is more of a risk-based approach, and this is done by providing means to empirically evaluate the risks that are associated with producing the synthetic data and with this synthetic data that was produced. So, for example, and here I'm referring to the Working Party 29 opinion on re-identification and anonymization, inference, linkage, singling out risks. All of these risks are measured and assessed based on a comparison of synthetic data and the original one.
I see. I think I understand. I think this is again, it's interesting to see how, again, what is possible using this kind of tools. Maybe to take a step back from this. So because we talked about you talked about the gap between kind of innovation and privacy. This is also how we started, right? There's some kind of a trade-off maybe, but so you say when it comes to, because we talked, there's a certain kind of risk balance that you want to strike, that you need to decide upon, but then kind of this will then again influence the kind of the possible insights you can gain from synthetic data, and this again would influence the kind of potential innovation you could achieve. How does this all link together?
Yeah, exactly. And this question is exactly related to the title of our session today. But before going into that, just a little bit of history. So after GDPR came into effect in Europe, organizations in general had to react very quickly because most of them were not well prepared. And what happened is that most innovation projects and efforts that were based on data almost went to a complete stop. And then slowly a series of processes and controls were introduced, and they had the effect of slowing down the projects, and some of the things that used to be done in days now started to take weeks or even months. So this is also one reason why for many people there's a negative reaction to privacy regulations. So while we may see it as a positive thing for the individual, many people see it as a break and a barrier to innovation, or at least something that introduces unnecessary or unwelcome friction. So now we see an opportunity in this challenge, and this is definitely something that we're going through. and we believe that without personal regulations, personal data protection regulations, we would not be talking today, because the reason we exist is to help people provide the technologies and the tools that help meet those constraints. Now, going back now to your question, really the key to bridge this gap is the realization that we don't need people's secrets to innovate with data. What we need is the insights, so the general information that is in the data, but that is not specific to people, that is not something that will harm them individually, definitely not more than information that you will learn in general from the population. So to retrieve these insights, we rarely need to really have access to all of that information, all of the sensitive information about the individuals, because those are not needed to make the important business decisions. And it's really this realization that makes the difference, and it's with this realization that synthetic data starts to become a replacement, and a valuable replacement for real data, because it is based on the insights, not on those specific secrets.
Super interesting to see that you can somehow square the circle apparently with this. Wow. Okay, so I think this was more the general understanding of what is happening there. Maybe to make it a bit more applied now. Where is this maybe the most useful? What are application areas? I imagine anywhere where there's private personal data involved, but maybe what are the, like, where do we see this already kind of being used in practice?
We see it in a different of use cases. We see it also across a wide variety of sectors and industries. It depends on the degree of maturity. It depends on specific setups. One of the most common use cases that we see organizations starting with is accelerating working with external vendors or third parties. So organizations who collaborate with externals obviously do not want to risk sharing their sensitive data for a variety of reasons. And this slows down purchase decisions or the overall projects in general. So here, synthetic data serves as a replacement that can get everybody up to speed quite fast without waiting for, most of the time, lengthy paperwork. And that paperwork will just never protect the data in case of a breach, because if you do a paperwork and contract and then you share sensitive data, you still have all of that risk. Of course, there's paperwork, but the data is not protected. So here, synthetic data provides a much less sensitive replacement. So the external data sharing in these situations is one of the common use cases. Another common use case is around enabling advanced analytics, again, with much less risk for the individuals and for the organizations. For example, we have worked with the second largest German insurer to help unlock data safely for predictive analytics. Again, on the same premise of insights and not secrets, the customer data was used to internally. So this was not an external use; it was purely internal, but to dramatically reduce that internal risk. And here we had an acceleration of time to data tenfold, and the performance of the machine learning and predictive models that were developed on synthetic data was comparable to the original data. So it was a win-win situation. These use cases are in usually more mature organizations when it comes to the data practices. Of course, you need data and analytics department and so on. So it's something that we see in more advanced organizations. Some applications that we have seen, and this is not something that we have done at Statice, but we have met other researchers working on synthetic data now for imaging in healthcare, and was generation of brain image scans, and that was also fascinating to see that very complex data types such as brain imagery can also be artificially generated and convey much of the useful information.
Well, that's. I have to say, honestly, this is an example I didn't really expect. Interesting. So it doesn't only apply if you want to kind of table data, list data. Well, you could transform everything into kind of table numeric data, but it's surprising for me to hear that it would also work on image data, for example. Well, maybe a short question before we move on. You mentioned time to data. Can you just maybe quickly tell me what that is?
So time to data is, in a nutshell, from the moment that, imagine you're a data scientist, for example, working at an insurance or at a bank, and you have a business problem to solve. Hopefully you have a business problem to solve and you're not just wanting to explore the data for the sake of it. And when you're thinking about your business problem, you're asking yourselves, where can I get the information that will allow me to solve this business problem? And if I'm going to build a model, what kind of data will be needed to solve this specific problem? And there you start an exploration phase, and you will say, okay, for solving fraud detection, for example, I would need a history of all the transactions and then the outcome, whether the payment was made or not, or whether it was asked for a refund or such things. So this is something that you define, and you usually what you would do is you would issue a request to get that data set, and then this request will get reviewed, and then there will be a process before you get access to anything. And then once you get access to that, you'll have to explore that data set and then decide whether that was actually meeting your expectations, or does it meet your needs, or do you have to go back and ask for something different or adapt yours. And at the end of this process, you'll end up with something, hopefully, that you're happy with. And then you can finally start the work. So that's what we call the time to data. And in general, with highly sensitive data in regulated industries, this time is very long due to the processes and due to the risks that are involved. So there are a number of measures that are in place for good reason that make this process slow to the point that it's in some situations very detrimental to the innovation that's ongoing, because it's reducing the number of projects that can be started and completed. With synthetic data, because of its less sensitive nature, you can get access to your first version of the data set extremely fast, because it doesn't have to go through all of those checks. The checks are made at the beginning when you define the synthesization pipeline, for example, and say that, okay, we want to synthesize all of the transactions. And from that point on, you can simply access that synthetic data with a much faster track. And then maybe later on, at some point in time, you want to get to the real data for some reason, then you can take your time. But in the beginning, when you're working on your project and getting it started, you don't want to be slowed down already.
This sounds super interesting that you could shorten process time. This is something I didn't expect to hear when talking about synthetic data, but it makes a lot of sense. Maybe just one thing, just a quick interruption to our audience. If you have any questions that you would like me to ask Omar, please feel free to put them in the chat. We might have 1 or 2 minutes at the end to do that. Okay, let's continue, Omar. So you already spoke about, again, the kind of process time that goes down, and the kind of the privacy preserving, kind of also the balance with innovation, and how this all seems to make a lot of sense in business scenarios, including healthcare, as I heard. Where do you think is this heading in the future, like in terms of technology? Like what's what's on the horizon, what is the industry talking about, and then kind of what is business kind of expecting from this kind of looking into the next years.
Yeah, that's the good question, and I think it can be maybe split into parts, and I'll take it that way. So 3 to 5 years from now, what we expect is that privacy enhancing technologies overall will have gained more adoption in general and be more democratized. Synthetic data is part of that, but it's not only a privacy enhancing technology. But there are others that are in much earlier state of maturity, but I expect and we expect them to grow in maturity and in adoption over the next 3 to 5 years, and hopefully will not be thinking about privacy technologies as something that's super new or something that's super innovative and nobody's doing, but more that something that's the standard, and it's there everywhere, and most organizations hopefully will have had that already deployed and implemented. Of course, with the benefit for the data subjects and for the individuals that their data will be better protected and eventually suffering less from the leaks and from the data breaches that we see today, more or less on a daily basis. Gartner, for example, predicts that for synthetic data specifically, that by end of this decade, most of the data will be artificial and will be synthetic. So really, what we expect is that privacy will not be an afterthought. So it will be part of the normal business practice and of the normal data organization practice, and not something that we will be plugging in after everything else has been said. But beyond privacy, of course, there are the discussions around the AI systems and the AI regulation, and that's also something that we see going forward as applications of synthetic data that are beyond the privacy. So how can synthetic data help develop better AI systems? The most obvious way is to improve the data quality and to control the data that you're training your AI models on, fixing issues like missing data or inconsistencies or biases, imbalances, but also improving the AI model performance itself. So if you have an imbalanced data set with, for example, synthetic data, you can rebalance it and improve the end performance of that model. So these are all use cases that we see going in the future, that we have started seeing among some of our, let's say, most mature and most advanced customers, but it's something that is growing in its adoption, and we see it going forward to be one of the major use cases.
Yeah, it sounds interesting to again also look into what happens then with the data, right? It doesn't like time to data, that kind of part of the process is not the end of the process, right? This is, I see. So it makes sense to also take this into account. I understand that. Okay, maybe also to kind of to wrap it up a bit. Last question from my side at least. So we talked about synthetic data as something super useful for privacy. Because again, it balances innovation and personal data, and you mentioned kind of as a way to kind of correct for data imbalances, for example, in AI applications. I guess you could also use it for non-personal data, for example, right? You could use it virtually. Like this, the algorithm that you use is like you can change it. So maybe other kind of, even like looking across, looking kind of further to the horizon, are there other examples where this is a useful tool to kind of kind of sample and try to kind of regenerate data for other purposes, for example?
Yeah, definitely. So, and the reason why synthetic data has been used historically for personal data was that the barriers to access for personal data were and are very high. Now, but the main pain point there was that there was a barrier to access, right? So for the other types of data that you mentioned, there the barrier to access is the data collection. And where do you get your data? How expensive it is to collect data? For example, we see in the automotive and self-driving vehicles industry where the cost of acquiring data or collecting the data and the footage is very high. There they rely heavily on synthetic data, simulated driving scenarios and simulated scenes that are completely artificial, and they use those simulated scenarios to train self-driving algorithms. So there, it's not really about the personal aspect. It's about how the amount of data that you can generate and the variety of scenarios that you can simulate in order to better train your AI systems.
I see. This is also super interesting. Wow, I'm really surprised again that there's because I was always thinking about it as a kind of privacy only technology, but now it's much more than that. Wow. Okay. Interesting. Maybe Omar, just so because we have 1 more minute, maybe if there's one thing that you would like the audience to kind of keep in mind after our interview, after our conversation, maybe there's something that comes to your mind that you that is maybe like the main takeaway about this.
I would say the main takeaway about this, and we are in a privacy conference, and that's something that I mentioned in the beginning, is that the key is that privacy and privacy regulations, the goal is not to stop innovation. The goal is to safeguard the privacy of the individuals and to protect that. And that there are ways to bridge those together, and that's the mindset that is important, and that's the takeaway of what I would like to be the takeaway of our conversation today.
Thank you so much, Omar. Thank you for being with us. This was, I think, very inspiring what you told us.
Thank you
so much.
Thank
See
you,
you.
David. Thank you again. Bye.
Yeah. See you. Bye bye.